The shortcut button to open the acquisition configuration window, this one here, will be enabled if a spectrometer is connected to the system and has been successfully detected and initialized by Libsoft. Selecting the shortcut button will display the configuration window on top of the main Libsoft screen. The parameters displayed in this window are virtually the same irrespective of the hardware components used. At the top of the screen are parameters that specify the number of laser shots that will be fired to acquire each spectrum and how many spectra will be acquired when an acquisition is initiated, these ones here. These parameters are as follows. The number of sample conditioning shots. This is the number of laser shots that will be fired at the start of each measurement before any spectra are required. These shots will be fired at the maximum repetition rate of the laser and can be used to clean dirt and debris from the surface of the sample when spectra from the underlying substrate are required. The number of accumulation shots. This is the number of laser shots during which data are required to generate a single spectrum. The number of spectra. This is the number of spectra that are required at each measurement location. The number of measurements. This is the number of measurement locations from which spectra will be acquired. If the LIB system includes either a manual sample chamber or no sample chamber at all, the user will be prompted to move the sample between each measurement. If the LIB system includes a computer-controlled sample chamber with 2 or more stages, the number of measurements parameter will be grayed out as shown here. Using such a sample chamber, a raster pattern of measurement locations can be specified using the following 2 parameters: the number of points per line and the number of lines. These 2 parameters specify the dimensions of the raster pattern of measurement locations. The total number of measurements is calculated as the product of these values, and the number of measurements parameter is updated accordingly. These 2 parameters will be hidden if the LIB system does not include a computer-controlled sample chamber. As an example, if the parameters are configured as follows, so number of conditioning shots say 20, number of accumulations 10, number of spectra 5, number of points per line 4, number of lines 3, the system will acquire spectra from 12 measurement locations in a raster pattern consisting of 3 lines of 4 locations on each line. At each of these 12 measurement locations, the laser will fire 20 conditioning shots to clean the sample surface and then acquire 5 spectra, each consisting of an accumulation of data over 10 laser shots. Also in the top section of the configuration window is a checkbox labelled MBAS. MBAS stands for Move Between Accumulation Shots. The MBAS checkbox allows the analysis location to be moved between each laser shot that makes up the acquisition of a single spectrum. Using the MBAS option allows the acquisition of data from the sample surface only and reduces the effect of interferences from the underlying substrate. This can therefore be useful for analysing surface coatings. The surface coating does, however, need to be uniform over the area analysed. With a manually controlled sample chamber, the user will be prompted to move the sample between each accumulation shot. With a computer-controlled sample chamber, the sample will be moved automatically between accumulation shots, and they can be specified in a raster pattern using the number of points per line and number of lines parameters. So if MBAS is enabled, the number of accumulations is calculated as the product of the number of points per line and the number of lines. So points per line is 4, lines is 3, so the number of accumulations is 12. The number of conditioning shots will automatically be set to 0, and both the number of spectra and number of measurements to 1, and these parameters will be grayed out and disabled. Also in this top section of the window, if there is a computer-controlled sample chamber connected to the system, a second checkbox labelled Return to Start will be displayed. If this option is checked, the X and Y axis stages will be automatically returned to their starting positions following completion of a scan of the sample. Finally, in this top section of the window, there is a Remote Trigger checkbox. This one here. This option will be enabled if a suitable I/O device is connected to the system and both detected and initialized by Libsoft. There is no I/O device connected to this system, and so it's disabled and greyed out. If enabled and this option is checked, when an acquisition is initiated using the Acquire button, this one here, the software will wait for a trigger from an external system connected to the I/O device before performing the specified acquisition. And when the acquisition is complete, it will issue an output signal to the external system to indicate this, and that the system is ready to perform another acquisition if required. The Acquisition Abort button in the toolbar, this one here, must be selected to exit this waiting state and return Libsoft to the ready state. In the central region of the acquisition configuration window, there is a Zoom checkbox, this one here. And if this option is checked, two further parameters are enabled, center and window. Enabling the zoom option means that when spectra are subsequently acquired, the display will automatically be zoomed to the wavelength range specified by the center and window parameters. The center parameter specifies the center wavelength of the displayed wavelength range, and the window parameter specifies the wavelength range either side of the center wavelength that will be displayed. The zoom function is useful if a specific peak or region of the spectrum needs to be checked following each acquisition. Note that the full wavelength range of the attached spectrometer is still acquired and saved, and the displayed range can easily be expanded to show this full range. The lower section of the acquisition configuration window contains the parameters used to specify the file names of the saved spectra. These ones here. The data folder parameter allows the folder to which both the analysis and background spectra are saved to be specified. This can be done using the folder browser button, like this, and selecting the current folder, or by typing a path directly into the control. The sample name parameter specifies the root name to be given to the acquired spectrum, so currently called sample. By default, a numeric value is appended to the sample name and is incremented following the acquisition of each spectrum. This avoids the need to update the sample name for each new spectrum and the possibility of spectrum files being overwritten. The starting value appended to the sample name can be set as this increment value here. It's currently set to 1. And this option can be disabled by unchecking the increment checkbox. When multiple measurements are specified for an acquisition, an indication of the measurement number is also appended to the file name. Similarly, if a measurement consists of multiple spectra, these spectra are saved in a single file and the file name is appended with an S to indicate this. The details of the file naming principles used by Libsoft are described in the video detailing the acquisition of spectra. The name of the background spectra acquired by the system can also be specified. This only really applies when using Avantis spectrometers, as background spectra for the EMU spectrometer are held in memory in Kestrel spec and not saved to disk. The parameter values currently displayed in the acquisition configuration window will be saved to the Libsoft configuration file when the application is shut down and automatically reloaded the next time the application is started.